All right, good afternoon and welcome to this lesson. This is grade 9 coding. It is the 14th of July 2020 and we are doing nested loops in Frozen, puzzle 1 to 6. So we finished nested loops with B yesterday, which used to be nested loops in a maze on the previous naming standard that code.org used for their lessons. And so we'll see how this goes. It's basically the same thing, just applied on a different type of puzzle, but it's good that we practice the same thing over and over again. It is important for us to see that, and this will also then be the last lesson that is purely aimed at that. From here on out, our lessons will be using them, but they're not aimed at teaching that specifically. My name is Mr. Paul de Klerk. I've been coding for quite some time now. I use it to create content on the internet. I am a web developer, not a web designer, and that means that I build systems that people use on the internet, and I create digital platforms for them. And then obviously, if they give me designs that was created by a graphic designer, I incorporate that. So my main focus is to get everything to work the correct way so that it functions properly on a cell phone and on a computer and on a tablet, and so that all the internal structures work the way they're supposed to. So that being said, I've been teaching coding here with the STEM Digital School now since June, April, just before April. Yes, I think just in April I started with them, and I've been thoroughly enjoying it. I started with the grade 4s and 7s, and now I am the entire senior phase coding teacher. So for those of you that are watching on YouTube, if you're not in our live lessons, you can head down to the video description box below if you'd like to come and join us in the live lessons. Just bear in mind, currently with the load shedding happening, there are some times that we have to create pre-recordings. I had to do that for one of my classes that will be happening later on today because I will be having load shedding at that time. So there might be some times where pre-recording will play, but my details are always at the end of the slides. At the end of the lesson, you see my email address there. So if it wasn't a live lesson and you have questions, you can send it to me on email and I'll still get back to you once our power resumes, once we have electricity again. That being said, if you are new here, please respect the chat box and please don't play with your video camera. It blocks the content on the screen, so I cannot see what I have to teach. Awesome. Let's get going. So here's a quote from Mark Zuckerberg. It says, programming is like any other sport. You might know the rules, but you have to play to learn. So I fully agree with this, especially on the platform that we're on. When we finish this lesson, you have that link open in your browser tab. So you can then save that link on a text editor if you'd like, or you can just keep your browser tab open. And then you can keep coding on this platform, even though we're not in the Zoom lesson at that moment. And you can continue to practice this. There are some puzzles as well within the code.org Express course, the one we are doing, that is free play. So we don't often spend a lot of time teaching them because it's free play. I don't want to place restrictions on you as to what you can do. But it is one of the best places that you can see if you have the ability to really understand the code and not just work with the, not just complete the puzzles as they are, but actually use the code to create something that is new and different, and that way is the best way for you to understand if you, or see if you really understand how to build a coding structure. Okay. So I'm going to move on to this. Here you can see we have functions and variables. Okay, so these are still a while away for us. At this stage, I hope you have a good understanding of statements, sequences, loops, nested loops, and then conditionals. So loops and nested loops, they're very much similar. It's just one inside the other. But the conditionals, functions, and variables, these are the more complicated ideas and concepts. And we will look at conditionals, then at functions, and then at variables. Okay. So a function is a sequence of code that performs a task or calculates a value. A variable is, or variables are placeholders for information that can change. Here is the lesson we'll be doing today, nested loops and frozen. So I'm going to jump to that coding screen and we are going to get started on that. We're doing puzzle 1. We finished nested loops in B yesterday. I just want to share the link with you in the chat box. There we go. Right, so I'm just going to click this off to structure my screen. And while you navigate to where you need to be, I'm going to explain this. So, hi, I'm Elsa of Arendale. Help me draw a shape. Draw a hexagon with 50 pixel long sides. Okay, to draw a hexagon, you will need this and this and this and this. Okay. So we're starting with something very simple, and then it's going to progress. I would like us to finish this lesson completely today. So I'm not going to chat too long on this. I just want to get going. Here we have the move forward that we're going to use, and we can see there at the top, it's 50 pixels long. We're going to turn right by 60 degrees, and that is going to be our first line and align us for the second line that has to happen. It's a hexagon, meaning it has 6 sides. So we need to repeat this by 6 times. And there we have our hexagon drawn. Perfectly beautiful, everything's fine. If you really want to, you can change the color there to any one of these. It doesn't give you a whole list of options, but there are some that you can choose from. And there you can see what it looks like each time it differs. Okay, so that's puzzle 1. Are you happy with that? Are you good to go? Can we continue? Type a yes in the chat box if we can move on. Awesome. After your hexagon, turn right by 60 degrees, then draw a line that is 150 pixels long, then jump to the middle and the center. So we're going to draw the hexagon. There's the code for the hexagon. So we don't have to do anything new there, right? I just want to close that up. Oh, no, I'm so sorry. I think I just stopped my screen share entirely. Let me just jump back. I hope nothing was interrupted there. So we are going to draw our hexagon. Just type a yes if you can still see me and hear me fine in the chat box. I accidentally clicked on something to get it off my screen and then it just jumped to the other desktop. Okay, cool. Right, so we're going to draw the hexagon. There's the code for the hexagon. Then we're going to turn right by 60 degrees as they tell us to do. We're going to draw a line that is 150 pixels long. Now remember, you want to use the move forward to draw lines. If you use the jump forward, she's going to move but not draw an actual line. Then we want to recenter again. So we're going to jump to middle center. There we go. That happened really quickly, but it happened. I just wanted to slow it down because it's important for us to identify the sequence. There we go. Okay. So I think we can continue. I'm just going to drop the new link there so that I can keep better track of this. Right. So now we're going to turn the code into a snowflake. And we are going to all of that code into another repeat. So I'm going to go slow with this, but all you actually have to do on the coding screen is put everything into another repeat, make that repeat happen 6 times. Now, when it runs, you'll see it's drawing, or she's drawing one hexagon there, right? So she's going to continue there. She's drawing this line and she's turning to draw that line 60 degrees. And when she comes back, she's still facing that way. So when she draws the second hexagon, she's going to draw it overlapping this one. And then she draws this again. You'll see that's not drawn yet. Now she's going to draw that on this side as well. When she draws this last hexagon, she's going to draw that one. Okay, so we can speed this up so that we can just have the end product available for us to see. Awesome. Now what you can do here to help yourself understand is set the hexagon's color to one color and set the line's color to a different color, right? So like that. Now you are going to see a big difference here by looking at when she draws that line. That one is pink. Now it's turning purple. Now you see when she draws the next hexagon, that one is back to pink again. So what is happening here is, remember we said in the beginning, when we did the code in the artist, when we're working on a canvas, whether that canvas is blank or whether it has a background like this one, it happens in layers. So the first code is not only going to run first and whatever's after that run after that in a sequence. It's also going to place down the images or the lines or the graphics onto the onto the play area in layers as well. So the first code is going to be executed first, which means it's going to be the first layer on our play area. Okay. And that's a bit of graphic design jargon. I'm not too stressed about that, but it is important to understand when you are going to use code to create graphics, right? Instead of just coding. The only catch that we have is there. So you see that last one remains purple. It's difficult to see because the colors are close. But if you really want to also make that one look the same, you can just add a small move forward there and decide how long that has to be. So for that to really take effect, we're going to have to run everything and just see whether 50 is long enough. No, this we have to obviously set back to that color. We just try that again and show you that. That's the pink we used, I think. Let's run that one more time. There we can see it worked. Okay, so now she's actually drawn that short line there pink as well, because she doesn't cross this path again when she's going through the actions of the loop. But this is not necessary. The colors are also not used. When we move on to the next puzzle, it just doesn't retain the colors. That is just for yourself. And then I can also use it to explain a bit more. Right, so this icon means that whatever code we create here is going to continue on to the next puzzle, right? And that is really important for us to understand. It allows us to do a few nice things, and I'm going to show you what they are right now. So before we even start creating the new code, we obviously have to add these little blocks. You can see there what the specs of the blocks are. I want to add comments in the code here and here. And there's a very good reason for this. So the first one we're going to call a hexagon because it's drawing a hexagon. That's what this sequence does. The next one is a long line, okay? Not a long line, a long line. And that's what that does. So now once we add this, we can just call that the code for the square. Okay, now this becomes important for a couple of reasons. I'm going to explain it to you after we've created the code for the square. So we've created enough squares to know that a square happens in a repeat. Excuse me, that repeats 4 times. So we can just start with the repeat. We don't have to start by creating the sequence and testing that because, as I said, we already know that this is going to be repeated 4 times. So now we want to move forward 15 pixels because that's what they say here at the top. That's 15 pixels. And we're going to turn 90 degrees. Now you need to just pay attention. This square is to the left of the line, so we're going to draw it left. Now this helps us to also understand. After we've drawn the line, we're drawing the square, so we have to turn left there. I'm going to run this. Oh, I did the same problem earlier. I forgot. This jump needs to move to the bottom of this code there, right? Otherwise, we're jumping back to the center after we've drawn the line before we draw the square. This is 19, not 60. Now it should work. Yes, there we go. So you see now I've tested and adjusted this code 3 times within the last 20 seconds, if it's that much. So it shows you how well practiced I am at using that problem-solving workflow. It's a part of the way that I think. It's not only something that I know. It's a part of the way that I think, and it's a part of the way that I act, because I think in that way. So now I want to show you these comments. A comment is there to help you understand and organize the data that is here, but it doesn't act on the squares or on the code. It doesn't actually run as code, and it doesn't add to your block count. And I'm going to show this to you here. So over here, it's easy for us to see, okay, without the comment, that's the hexagon, that's the line, that's the square. Once you come here, it becomes a little bit more tricky. And this is now only, let's see, what do we have here? 1, 2, 3, 4, 5, oh no, 5, 6, 7, 8, 9, 10 lines of code. And we're using 3 comments to organize that. So on 10 lines of code, I mean, using comments or not using comments, you can still sort of keep track of what each section is doing just off of memory. But imagine you're creating 100 lines of code, and it's something that you're going to work on again or improve on in a year's time. There's no way you're going to remember exactly what sequence does what. Also, imagine if you're working in a team. You are collaborating with another creator on that, or another programmer. The more accurately you use comments, the better for them as well. So here are the comments. You can see they have these 2 forward slashes and a space. And that means the computer doesn't read that. That's only for us to know what this code does, right? It's not going to try and act on this. It's not going to try and implement this as code. It'll only implement whatever is after and before that. And you see, I like to use uppercase letters, capital letters. The reason is, if you have a look at the JavaScript, most first words are done with lowercase letters. Not all, but most. Only the second word to show where the new thing starts, right? The new, you could say, variable starts, it is an uppercase letter. So if I also use uppercase letters in my comments, it makes it a lot easier for me or somebody else to read, which is the reason why we use it. That is all the way you do debugging. So now, if I realize that there's a mistake somewhere, so let's say this, as I had earlier, this was 60 degrees, right? If we run the code, we can see there's a problem there. Something's not working the way that it should. Okay. So the entire thing is not working correctly, just because that's changed to 60 degrees. Now I can, there are a couple of problems here. First one, she's not doing the others, right? So that's one problem that we have there. But the first problem that happens, the hexagon is fine, the line is fine, the square is not fine. So this is where the big mess comes in, is in this square. So now I'm not going to mess with the code here, because this is the code for the hexagon. The hexagon is fine. Why would I change anything there? This is the code for the line. I'm not going to change anything there. This is the code for the square. There is obviously a problem at the square. So we need to change the code there. If you start just changing random things all over without having comments and accurately identifying where to make your adjustments, where to fix your mistakes or someone else's mistakes, or where to implement updates, it makes it very difficult. You might change something up here, and you saw now, we change this to 60 degrees. Not only does it affect the square, it affects the entirety of the code, the way that it's run, because the turns and things here are relying on this to be a full closed square. So you can imagine now if you came and you adjusted this. So let's say this is still 60. That's where the actual problem is. And we just come start practicing to see what's happening. We change that to 90. Now look at that. It's beautiful though. It looks cool, but you see the problem that it creates. So now you see, that doesn't really help, but it almost looks better because this is working. Okay, cool. And now, okay, let's carry on. So you see, oh, there's a problem. Now I fix this. Then you run it. Now the code is still not right. Now you are still feeling lost and confused. What's happening here? I don't understand this. I fixed it now. So this is why it's very, 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 very important for you to use this approach where you comment and label each sequence. If I can see the first mistake that is creating problems is with the square, I'm going to start here, even though it's at the bottom, even though it runs last. I'm going to start to look for issues here. I'm going to debug from here and then go all the way back. Now, to identify that is where we use the step button. Now, we don't have a step button in this, but we have a way to make it slow. So if we run this slowly, it's very similar to having the step button. In order for us to identify where the first mistake is, we can see that's working correctly. This is working correctly. There we can see that's a problem. Okay, so similar to the step button. Okay, does this make sense to you? Do you understand why we want to use these comments, and do you understand this code? Okay, this is vitally important. I don't want to bore you, but when I see something that I know is going to help you out on everything that we're doing from here on out, I'm going to spend a bit of time on that. In the future, if you would like to send me something, copy this link here and send that to me if it is available, because if some of you are copying this link here at the top, it just sends the blank puzzle to me. That doesn't help me. You can do this or you can screenshot it. I see some of you yesterday did send me homework and you did screenshot it so I could see properly. All right, so this is again one of those things. I'm going to share this puzzles link with you. Excuse me. Right, so this is one of those things where you can see the power of having that these comments again. You can see what's happened is try to change the shapes or the lengths of the lines to make this your own. So you can either go and create something new or we can replicate this. Now look at how easy this becomes. We take this out because we know we always have to go to the middle after we've done everything. This is the square. Move that to the side. That line is out. The hexagon is out. Place the square first because it's going to happen first. Place the line first. It's going to happen second. I'm lying, not first. Place the hexagon last because it's going to happen last. Instead of deleting everything, instead of hitting the start over button, not that this one has one, but you could have just deleted everything off here. Look at how easy that was. It's still not perfect. I'm just going to run it because obviously the sizes aren't good, right? But now, okay, this again looks nice, but it's not what we're aiming for. Again, I can go to the specific location where the problem is. The square is too small. There's the square's code. There's the one that dictates the size. And I make it bigger. And I run it and I see, beautiful. It is larger. That works. Now I saw this is too big. So I'm not going to change anything. I'm just going to leave this be. Go to the hexagon. Check this because this is the one that dictates the size. Change that to 15 to make it smaller. Run it. And look at how close we are. So the only thing now that we need to take into account is the direction that we're turning, right? Remember when the Hexagon was at the top, it turned right. When this was at the bottom, it turned left because of the way that they're situated. So we just need to swap those around. And there we have our entire pattern perfectly drawn. So you can see why these things are important, and you can then again adjust some things, set the color and so on and so forth, if you'd like to do that. Are you happy with this? Does it make sense thus far? Can we move on to the last puzzle in this lesson? We're flying through this, so we can actually even start with a new one. Okay. Anyone else? Awesome. So we're going to continue. Just excuse me for a second. I'll be back just now. There we go. I'm having a bit of an allergy attack today, so that's why my voice is making funny and you hear funny sounds. I apologize for that. Okay, let's try something new. This time skate in a zigzag. So we look at the picture. We can also read further. It's going to tell us inspiration. Try changing your 150 pixel line into 6 short lines of 25 pixels each. Turn by 45 degrees in alternate directions after each short line to get a zigzag look. Where do you need to put a new repeat block to make this happen? How many times do you have to repeat your pattern of 2 short lines to get 6 in total? So we're going to remove only the line because we obviously, before we do that, just check this. If you don't understand this completely, look, you can see the square is still the same, the hexagon is still the same, the line changes. So I'm going to remove the line from my entire sequence, move everything away, and just build the line. I'm going to throw this away, and we're going to say move forward by 25, because that is the specs that they gave us here at the top, 25 pixels. I'm going to turn right by 45. Now, this is something that you need to pay attention to. We're going to move again, and we're going to turn again. Now, this, we do not know yet necessarily. I mean, you could probably, by looking at that line, identify exactly if you're turning right or left first or whatever. But for now, the easiest way, because this plays with my eyes, I can't really see those shaded lines very clearly. So instead of worrying about trying to figure out which way to turn first, I'm just going to set 1 to right, 1 to left, because I can see it's a zigzag. I'm going to run it, and I can see we're good to go. If I was not happy, I could just change this around and run it. And then I can see, that's really not good, right? Because there's a line going there. And we can see this is ending up here. If she follows along this path, she's going to be next to that. So we can just adjust it like that and run to test. Now, we need to draw 6 lines. This is drawing 2 lines. So we have to repeat that. And we want to make 2 things 6 times, then we're going to do it like that. Okay, so now we see our line is good. There are no problems in our code there. So what we do now is we place this back there. Excuse me. I took antihistamines earlier, but it doesn't seem to be working yet. So let's just push on. So now we've placed the line back to where the line was before. We can run this, and we see that works, but there's a bit of a snag here. Okay? So that's fine. The line is good. This is good. This is good. So now we can think the square is good. We don't want to adjust anything there. The line is good. We don't want to change anything there. The hexagon is good. We don't want to change anything there. But this is not a part of the hexagon. So what we can actually do is add another comment there to call that the position, because this is changing the position after the hexagon has been drawn. And we can see that to jump to the middle only is not efficient anymore. So we want to turn as well. So you can either turn and then jump or jump and then turn. It shouldn't make a difference. And now we test it and it works. Okay, so let's test it the other way around. Jump and then turn. Just see if I am correct in my statement. Yes, it still works. Okay. Right, there you can see, again, by using the comments, we can easily identify where the issue is at, and we can just sort it out. We don't have to go and fiddle with other code again and make things difficult for ourselves. And that's this entire lesson finished. So now you've learned nested loops and you've practiced using comments. Are you happy with that? Are there any questions on this? Can we start with our new lesson 10? So type lesson 10 or just the number 10 in the chat box if we can continue to lesson 10. If you need some more explanation on nested loops or comments, then just type help. Okay. If I look at this, it doesn't seem like anyone has any input, so I'm just going to continue to lesson 10. Okay. Quizzy says 10. I thought you'd be ready for this. Minecraft. We cannot look at this video on our lessons because it creates copyright issues when we upload it to YouTube, but you can watch those videos by yourself. Okay, so here we have Minecraft. Either than those ways, is there a different way of doing it? So those ones that we just finished, there is a different way by not using repeats. And that would be entailing writing all the code out all the way, right? That is obviously not going to be so efficient, but yes, you can do it that way. And then also remember, Luco, those first or those previous puzzles, they give us inspiration. So they give us ideas, but it doesn't mean that you have to follow those ideas. You can go and create your own designs there. You can play with it as you want to. Those outlines that were there on the frozen lesson, they are only there for us to have an idea. Like me, I like that because, as I said before, I don't do digital design or graphic design or web design. I develop code. I don't make things pretty. So if they want me to use code to make things pretty, I need a design, and then I can code something to create that design. But to create a design out of my head, I'm not talented in that at all. It's not one of my skills, right? So they give us that for people like me. But if you are a creative person, you can by all means go and code anything in there and create any design that you'd like. And then I would also, it would be awesome if you share it with me. Okay, so Minecraft. Who of you plays Minecraft? Clear asking me privately, will we have assessment for coding next week? Yes, there will be. Luca plays Minecraft, awesome. I just quickly want to chat on this. And Quizzy, great. There will be informal assessments. Okay, so what that means is, this is obviously a new way of learning. Learning on the computer like this, you sitting at your home, I'm sitting in my office, and we're sort of connecting. I'm here in the garden route, you might be in Joburg, and we can still connect, right? So this is a new way of doing it. We are backed and have permission to do this by the Department of Basic Education. They're testing this all out because we are trying to create an actual school that will be full-time run like this. in order for that to be possible, we have to have the ability to do assessments. So what we're going to do is next week, we are going to do a dry run testing informal assessments, meaning we are going to do assessments, but it won't count towards grades for your actual marks for your actual grade. And coding isn't a gazetted subject yet. So that also, it's not going to help you out. There are other subjects where those assessments can be placed into a portfolio of evidence so that your teachers can have access to that once you can return back to school. If they need it, you can request it. Some of our teachers are doing that for their students. So for coding, just understand there isn't a curriculum yet. It is being developed. We are also developing a platform where we can do formal assessments like this, where we can sort of have control of the way that it happens to make sure nobody's cheating and everyone is being assessed to the same standard that somebody would be assessed if they were attending a normal school, right? So we are having informal assessments. So what is basically going to happen? I'm going to submit a document to my HOD where she is going to have links to different puzzles, right? So I'm going to choose different puzzles from the ones that we've done already, and maybe one trick one in a future puzzle that will deal with concepts that you've done before, but a puzzle that you haven't seen before. Or I might go and find a puzzle that is something that you're not going to do in this course at all. Anyway, I'll link to that. You'll be able to download that from the Africa Team Geeks website, go to the links, do them, and then we'll discuss them together in a lesson. That's going to be the bulk of our assessment. It won't be anything more than that. Okay. We don't have the time, or not the time, we don't have the resources in this coding on this platform to do all the theory that is behind it, because the theory is hidden in the line and text-based coding with all those syntaxes and punctuation marks and things like that, which is not something that you see. So it's not something that I will test you on. So it's going to be getting a few puzzles, playing, and submitting that to me would be awesome. If you don't submit it to me, then we can just chat about it in our lesson after that. But it would be great if you can send it to me. Okay, so back to Minecraft. I see some of you are playing Minecraft. My son and I, we play Minecraft on the Xbox One. He's 8 years old. We've been playing together for 2 years now, and he still refers to me as being a noob, right? So that is a new player. And whenever we play together, I get to be Alex because he's Steve. So I'm going to select Alex for this as well. Okay. Now, I just need to explain some of the Minecraft dynamics to you before we can actually code anything in Minecraft. So for this exercise, we're going to code our player, Alex or Steve, whichever you decided to choose. And we're going to make him or her do different things in the play area. So in Minecraft, everything is made up out of blocks. So please don't get confused when I say block and my mouse pointer is here, or I refer to the play area and speak about block. It's not the same as these coding blocks. These coding blocks are called Blockly blocks, B-L-O-K-L-Y. That's the system that any platform that uses these block codings, they're working on Blockly, okay? So blocks are here, and you can see the block is being circled where Alex is standing. The sheep is standing in a block, and certain things are 1 block high, like these ones. The trees are obviously 3 blocks high, so it all depends. Okay. So the whole idea of Minecraft is to gather resources and create stuff and build stuff. So you're going to be mining in actual mines. You can gather resources by farming, getting plants, shearing sheep to get wool, all of those things. And then you're going to be crafting a base for yourself, a place to stay, a house, all of that. This starts off very easy. Look, let me just do this. There, that puzzle is done. Okay. The reason is this entire puzzle comes out of the Hour of Code course that code.org offers. So they have these computer science weeks, and then they create these hours of code where a lot of people from all over the world get together and they just play on these things. So it starts easy and it increases in difficulty gradually until here at the end where it's an entire free play lesson. Right, so that is your introduction to coding in Minecraft. Now, the actual physical Minecraft game is based on JavaScript, What we're learning here is JavaScript. So just think about that for a second. The actual game Minecraft, developed by Mojang, is based on JavaScript. You are here learning JavaScript fundamentals. So imagine where that can put you in 10 years' time if you actually stick to this. You're grade 9 now. If I started to learn coding and focused on something like JavaScript when I was in grade 9, imagine where I would have been today. I would have possibly been able to code an entire computer game if I wanted to do that, right? I could have had the ability to do that because you are now already ahead of people that are not learning to code. So if you're an avid gamer, especially not just Minecraft, many other games also run on JavaScript. It is the most commonly used coding language in the world, right? So just a few things to think about. So this one is for you, just add another block to get Alex to the sheep. As I said, these first 2 or 3 are intros. So that's why I wanted to hopefully get to them today. So I'm going to do at least 2, maybe 3. Okay, so here you can see wood is a very important resource. Many things are made from it. Walk to the tree and use the destroy block command to chop it down. So you're going to move forward once, you're going to move forward twice, and you are going to break the tree. Obviously, if you want to destroy a block in Minecraft, you cannot be on top of that block. Well, you can technically, but for this, you have to be next to it. So we just move until we're next to it, we break the tree, and we gather the wood. Okay, and now we're going to do this last one. And I'm going to leave you with this link. Sheep shearing time. Use the shear command to gather wool from both sheep. So we need to shear both of them. We're going to move forward twice. You see there aren't even repeat blocks here. We're going to shear that sheep. We're going to turn right. We're going to move forward once more, and we're going to shear that sheep. And that looks a bit weird, but right, so this is basically what we are doing here. And you'll see it continues to where around here we actually build a house. Not an entire house, the foundation for a house, the line out of that house. Okay, the homework is if you can just spend some time coding on the Minecraft lessons, and you can go back to this last lesson in Elsa and create your own design. So you can either spend time doing the Minecraft stuff, because this is not necessarily fun to everyone, but for those of you that are creative, if you can go back here, create something and share that with me via a screenshot, that would be awesome. So tomorrow we will continue with concept practice with Minecraft, puzzle 1 to 6. We've obviously done up to there, so we'll move this along so that we're doing a few more puzzles. And then if you have any questions, you can mail it to me there. If you've done the homework and you'd like to share it with me, you can mail it to me there as well. And you can find us on Facebook, Instagram, Twitter, and YouTube, searching for Africa Team Geeks. That's it from my side today. Thank you so much. I'll see you again tomorrow. Bye-bye.